All right, so this is section 3, and in this section we are going to be looking at geometric sequences. So these work a little bit differently than arithmetic sequences. From one term to the next, we're not adding the same amount or subtracting the same amount. Now we have a ratio where we're multiplying by the same amount. So 4 times 2 would be 8. 8 times 2 would be 16. 16 times 2 would be 32. We can see that if I subtracted, this difference is 4, this difference is 8, this difference is 16, this difference is 32. And so it's not the same difference every time, but it is the same ratio. So these have a common ratio. And you can find that by setting A2 over A1. Really, the second term over the term before is and works with any terms. I could do the fourth term over the third, or the third over the second, or the second over the first, or I guess that would actually, there's 5 terms here. So that would be the fifth over the fourth over the third over the second over the first. Any of those work, or you can just use the first and second every time. These numbers can also get smaller. They can also alternate signs. So if I have 9 times negative 1/3 would be -3, times negative 1/3 would be 1, times negative 1/3 would be negative 1/3, times negative 1/3 would be 1/9. Our common ratio is negative 1/3. So geometric sequences also have a recursive and explicit formula. The one you really want to know is that explicit formula there. And like we did with arithmetic sequences, we can use that formula to write a general form. So a sub n is equal to a1 times r to the n minus 1 power. That's this formula right here. And I can plug in the information I was given. My first term is -4. And my common ratio is -2 to the n minus 1 power. And so that's the general form of my sequence. So I can find the 8th term by plugging in 8 and then -1. So -2 to the 7th power is -128 times -4 would give me 512. Okay. The next example says, write the first 5 terms of the geometric sequence when A1 is 10 and R is 1/5. So my first term is 10, and I want the first 5 terms. So the second term would be 10 times 1/5. 10 times 1/5 is 2. 2 times 1/5 is 2/5. 2/5 times 1/5 would be 2 over 25. 2 over 25 times 1/5 would be 2 over 125. And those are the first 5 terms. This last example says, write an explicit formula for the geometric sequence where we know the 7th term and the 10th term. So I don't know the first term, and I don't know the common ratio, and I don't even have 2 consecutive terms. So what we're going to have to do is write an equation for each of these. And a sub 7 we know is equal to 64, and a 10 is equal to 512. And we know the formula is a sub 1 times r to the n minus 1, and a sub 1 and r to the n minus 1. Well, what I can do here is I can choose one of these equations to solve for a sub 1. So I'm going to do that with this top equation here. And I have 64 is equal to a1 r to the, and actually, before I do that, let me rewrite both of these actually. So r to the, and then we're talking about the 7th term. So 7 minus 1 would be 6. And then here I have 512, A1R, and then here my, excuse me, my n value is 10, so 10 minus 1 would be 9. This top equation, I'm going to get A1 by itself. So 64 is equal to A1R to the 6th. If I divide both sides by R to the 6th, I get A sub 1 is equal to 64 over R to the 6th. And what I can do is I can plug it into the other equation to solve for A1. So 512 is equal to A1 R to the 9th, and that A1 is 64 over R to the 6th. Well, 6 of those r's can cancel out, and I'm left with 3 of them here. And so now I have 5, 12 equals 64r cubed. I can divide both sides by 64, and I get r cubed is equal to 8. And then I can take the cube root of both sides, and I get r is equal to 2. So once I have my r value, I can plug that back in here, and a1 is equal to 64 over 2 to the 6th power. And 2 to the 6th power is 64. So my a1 is equal to 1. So then writing the general or the explicit formula would be a sub n is equal to a1, which is 1, times r, which is 2, to the n minus 1 power. And that would be my explicit formula. And that brings us to the end of section 3.